Setting up in the STM32 environment can be challenging, especially if you're moving from an Arduino IDE, for example. This is the mini-series in which I design, program a dev board for a microcontroller I've used in the past, something that you've all seen before and quite familiar with. To kick things off, we are in the STM32CubeIDE launcher. This is something that you'll see as soon as you download the application. What I like to do is separate each of my projects out into a folder so I know everything is contained in there, as it can get cluttered quite quickly. Once you have designated your folder and such, we're going to click launch. Now that we're here, so if you're starting a new project, we want to start from here. We see a whole bunch of different options here, and there's quite a lot of resources that we can all read through. ST have done a fantastic job on this and makes things really easy to set up and build. So we're going to click here, start new STM32 project. It's going to start initializing something, the STM32 target selector. In this page here, we see a whole load of options. It can get quite overwhelming very quickly. And this is where we're greeted with all the ST microcontrollers, dev boards, examples, and whatnot. We can actually break this down into whatever we want, and it will actually provide you a list of what microcontroller you're looking at, and it's really interesting to see from. Instead of looking for DigiKey, mouse, or whatever, we can actually look straight from here. So really, I like to do a mix of both and select what I'm looking for. Maybe look on DigiKey, mouse for the price point, and then maybe I'll break this down a bit more. But even so, we can see from here, it's really good stuff. So our controller of choice is this one right over here. And before I actually click, you can actually click dev boards and whatnot, as I've mentioned before. So if you had a dev board you wanted to play around with, this is what you'll select, and everything will be pre-initialized for you. So like the buttons, whatever clocks they had done, everything will be set up for you so you can do your development a bit faster. As well as the examples, this is really good just to, if you needed something quick up and running, I highly recommend it, even to have a read through and see as well, take reference from and develop based off of. So we're going to click our microcontroller. Again, it's probably something you have seen before in the past. STM32F03, it is a TSOP 20 pin package. We click next. So you give your project a name. What is it going to be? We're going to put this dev board, because that's what we're designing. This is the project. Select your target languages, C, C++, and I keep everything the same here. Click next, you're going to see everything, but really we can just click finish. Do you want to open this perspective? Yes, we do. Fantastic. So now that we will be greeted with this page, you'll have your microcontroller of choice over here, and this is where the IDE is wonderful to use. It's so efficient. It's absolutely great. So we have all these pins here, and these pins correspond to the datasheet that you'll probably be reading when you're selecting your microcontroller or wanting to configure. If you click on any of these pins here, it tells you what they do. So if you see in your datasheet, you see some pins have ADC, some pins can be used for I2C, some is a reset pin, whatever. And by clicking on this, we can actually select what we want. So let's say, for example, okay, I want PA0 to be I want that to be a GPIO input. I want that to be my ADC input. Okay, maybe I want I2C. Maybe if you had 64 pins, you're unsure, like, I'm not really sure where is it. And this is where the different subcategories come in. So you can see all these GPIO, DMA, sys. You can see what you want. But let's say I want I2C. Okay, so we're going to click I2C, enable, and it's already automatically suggested which one is it that we can use for these I2C pins. Say we wanted SPI. We say full duplex master, and we get our SPI pins. It's absolutely great. Input, output. Okay, so we do that. Absolutely great. It's fantastic. I cannot really fault this whatsoever. It makes things so simple and easy to use just by flicking things on, off, whatever we want. So have a look around on this, what you want to do. And I would suggest when you're happy with your pins and whatever, I suggest giving it a unique user label. What will happen if you do not, we'll come up with an ultra-generated name in Microcontroller as this, and it makes your code kind of look clunky, it kind of looks messy. You want something that you can easily refer to, what pins you're doing. So for example, if I had let's say ADC1 input, I want to say this is actually my temperature sense. So now you'll see that ADC1 is now going to be called as temperature sense. And this is what I mean by it. You will easily reference to it, so you know that, okay, my ADC is coming from my temperature sensor, and this is why I need to refer to it. So do have a play around with this, get familiar, get comfortable with it. It's a really great tool. You may see on the top we have all these other options here: clock configuration, project manager, and tools. So within this clock configuration, this is where I probably had a bit of trouble understanding what all these options did, what they meant, and this is where we specify what clock system we are using. We have two types: external and internal. This basically means we can generate our own clock source and we can feed into the micro, or we can use the micro as internal clock source. As well as there are a few acronyms that I really had no clue on what I was doing. Then I had to really learn into them. But we'll break these down External clock sources. So familiar, you might see HSC, LSC. So here we see HSC, but what are they? What does it actually mean? HSC stands for high speed external. So this is an external crystal or resonator device that you can put into your microcontroller. So as you see on other designs I've done on this channel, I've had an external crystal being fed in, and this is usually the one that's I've usually put 32 megahertz, but this frequency range can be between 4 to 48, dependent on what you choose. LSC is the low speed external, and this is a 32,768 hertz clock. And this is also that I've used on other designs. I always have this low speed clock driven externally, and it feeds into the internal real-time clock module within the microcontroller. So these are the two external clock sources, the ones that you need to be aware of. Internal clock sources, HSI. I saw HSI here, HSI RC, and this is the accurate RC based 16 megahertz internal clock, and it's factory calibrated usually to 1%. Multi-speed internal, so this is MSI RC. Sometimes you'll see this, sometimes you won't. It depends on what you're using. And this is a multi-speed RC based clock source, providing a clock range of 100 kilohertz to 48 megahertz. So this clock can be trimmed by software, and it's able to generate a multitude of different clock sources. PLL, and this PLL is fed by the HSC, HIS or MSI clocks, so the things I've just listed off just then, and this clock can generate up to 80 megahertz. So you see in the settings you can actually select a few bit here, you can adjust the pre-scaler, and you'll actually get what you want. So you see it auto adjust depending on your selection, so it's quite cool actually. Some external things that you might see that may not be on the screen. Microcontroller clock output, MCO. So this is a clock output. It's possible from a special pin called microcontroller clock output, as I've just said, and this can be used as a general purpose or as a clock for another microcontroller, so you could feed this into another micro if need be. Low speed clock output. This is a low speed, so as just mentioned, of 32,768 kilohertz, and this can be a general purpose clock output as like the previous mentioned one. And all these things can be configured to your liking depending on the IDE yourself. So here we can configure everything as I've just shown, and it's important to configure the clock source dependent on your application, and this IDE does a really good job of doing so. We can see everything how we want it to be set. So you may be wondering, oh, I see like AHB prescaler, APB1 prescaler, what's this, peripheral clocks, timer clocks, what's all this going on over here? So what this is, and these further acronyms, is AHB prescaler. This means you receive the clock system, provides clock to the AHB bus, and this prescaler takes values from 1 to up to 512. So look, 1, 2, 4, 8, 16, 512. These are set values, and you'll see on the datasheet when you're looking to program, you'll see each of our ports and whatever has a bus related to it. APB1 prescaler, this prescaler receives the AHB clock and provides clock to APB1 bus peripherals. This prescaler can take a value from 1, 2, 4, 8, and 16. So it is this one here. This is talking about the bus again. If you look at the datasheet, you'll see each bus for each port for which GPIO you're on about. APB2 prescaler, not sure if this one has it on here, can't really see it, but I'll say it anyway, that this is a prescaler receives AHB clock, provides clock to the APB2 bus peripherals, and again this one can take value from 1, 2, 4, 8, and 16. And again, these things you may not see on every single microcontroller you use, but do keep them in mind. This is what they do. I highly suggest reading further into it, get your datasheet, compare it, and you'll see what I mean by each bus is in comparison to each other. So you may be wondering, why would I use an external crystal when there is one internally on the microcontroller? As we just said, saves me routing, saves me a bit of money on the crystals. I don't need to faff around with all this and see if my crystals tune correctly and whatnot. And the thing is, it really is dependent. Like a lot of things, it's really situational, though I must say that you need to consider the accuracy, because internally it is not that accurate, even though it just says factory trimmed, and it really depends on the accuracy and timing of your application and your project. So this is why it might be best for you to opt for an external crystal instead. Now that we covered the clock configuration, I'm really not going to change any of these for this project, as it's just a dev board. I can configure it anytime, anywhere, but I'm letting you know that this exists and whatnot. Project manager, this again, nothing really too much to go into. I've never really touched this at all, just some other things. Project name, toolchain. The thing at this point is that if you're just starting out, you don't really need to pay attention to this. As well, the tools part, I've never used this yet. I never had to. I guess when you get further into it, I'll probably find out what this all does. It probably is quite useful, but I'll let you know. But for now, if you're just playing around and trying to learn, I wouldn't even bother with it. So say you're happy with all this, you're happy with all your pinouts, and we are just going to save this. And it's going to ask us, do you want to generate code? This is the brilliant part in which a HAL layer is it's generated and code gets generated for us. So we don't even need to touch into the internal registers on what we need to select, because quite usually you would need to go in and, if you're writing up a drive or whatever, you would give the registers, you need to flick them ones and zeros on, off, or whatever the setting you want. But we're going to click yes. I'm going to click yes. So this is going to update, and there you have it. You usually be greeted with something like this. So this is very just a bare bone piece of code. Everything is stuck on your main .c file. It's quite nice because it kind of just guides you a bit on where you want to might include stuff, what you want to do with it, and you can see everything, all the functions that we've had, everything that we want has been initialized, and this is where you see all your values for what we've set. So depending on what you have set in that clock, this will all get changed dependent. So that is it for now. That's the basic setup. When we get further into this project and we start developing code, I'll start making changes to it, but I wanted to show in case this is how you get up and running easily to get into it. I think we're going to do some actual programmable support with this later. We'll wrap our head around it and see how to use this going forward.